Hello and welcome to the video lesson on the greatest integer function and the role of its parameters. So this is a screen that shows what the standard form is of the greatest integer function. And this is a window that has Desmos pre-programmed function. So the first thing to notice here is that this looks a little bit different. It's got the word floor in it, which obviously is not written here. This has brackets after the floor. This has these square brackets. So these are different, but this floor function is the Desmos version of the greatest integer function for which we use these square brackets. So remember that square brackets like this, when there's a comma and two numbers, are interval brackets. When there's just stuff inside, like brackets and numbers and no comma, those are greatest integer function brackets. And they mean to round the contents, once they're all simplified, down to the integer below. And in Desmos, they use the word floor for that because that is the level below your feet or whatever. So that's the Desmos version. And so that means that this is the graph associated with that type of function. So the way this one is right here, I have made sliders in Desmos. So it means that the A value here is 1, the B value is 1, the H value is 2, and the K value is 1. So it would be as if here I wrote this out this way. Although we know that mathematically that's not actually how we would write it. We would write it more this way. Because if there's a 1 in front of a bracket, we don't write it. And there's another 1 in front of this bracket, so we wouldn't write it. This one's added, so we do write it. So basically what that means is that this graph corresponds to this greatest integer function. And what I'm going to do is take a couple of minutes to show you what role each of those parameters plays. So right now my A value is 1 in what you're seeing here. But if I were to amend that, so I'll delete this out just so there's no confusion. If I were to change that A value to, let's say, 2, take a look at what happens to the graph. So that A value changing to a 2 is visual effect. If I go to 3, if you want to pause and just think through on your own, try to guess at what is happening before I tell you, that A value being larger is spreading out vertically the steps. It's changing the vertical height between steps. And if I were to make the A value smaller, like less than 1, 0.8, 0.7, 0.6, the steps are getting closer and closer to each other vertically. You'll notice that at the very edge of the graph, they no longer have dots. That's just because this version I had programmed it to contain a certain number of spots. And if I make a negative, notice that the steps, rather than forming an increasing from left to right staircase, form a decreasing one. Okay, so that's the value of A. So if I were to summarize, the role that A plays is the vertical spacing between the height, the height or the vertical spacing between steps. The B value right now is 1. If I make B, let's say 2, notice what happens visually. If I make it 3 or 4, notice what happens visually. If I were, on the other hand, to make it a smaller number than 1, like 0.8, 0.7, 0.6, 0.5, what's happening is that B has an impact on the step length, but it's an inverse one. So the larger B is, the smaller the step is side to side, and the smaller B is, the larger the step is side to side. And notice that right now, each one of these steps has a filled in dot on the left-hand side and an open dot on the right-hand side. If I change B to be a negative number, the opposite happens. The steps go the other way. And just like making the A value negative, the steps now decrease. If I were to make them both negative, then the B part being negative means that the step opens on the left, the inverse of what we saw before, and having 2 negative values means that the steps now increase again. So only one of them being negative, either one, the steps decrease, and both being negative, the steps increase. And finally, H and K kind of have a similar set up or look to the h and k in a quadratic function that we're written as x minus h in brackets. There's a fixed negative. So actually h being 2 would be written as x minus 2. And if you look at where x equals 2 is, and k equals 1, which is usually a y value, that corresponds to a filled in dot. And if I were to change my h value, which is side to side, to let's say 3, then that filled in dot moves to a position where it has an x value of 3. If I were to change it to 4, it moves to have an x coordinate of 4. And if I change the k value to be larger, then it moves up or down. I make it negative. So quick summary. In this format, A is the vertical spacing between steps. B is the inverse of the step length. H and K are respectively the x and y coordinates of a filled in dot. And if both A and B are the same sign, either both positive or both negative, the steps increase. So both positive or both negative, the steps increase left to right. And if only one of them is negative, the steps decrease. So I hope that gives you some insight into what the parameters do. Thanks for watching.